All right, section 1.9, the last section in unit 1. So an inverse, by definition, is a reversal. It's kind of undoing something. So if a function is a rule that dictates what is done to each input, then the inverse kind of reverses that process or undoes it. For example, if you have the expression x plus 5, to undo that, to do the inverse, you'd subtract 5 to solve for x. So in order for a function to have an inverse, it's first got to be a one-to-one function, which means it passes both the vertical line test and the horizontal line test. So the vertical line test confirms that each input has only one output, but how does that help us out with the horizontal line test? Let's take a quick look at an example of the quadratic function. So a basic quadratic function is a parabola that looks a little something like this. Not the perfect drawing, but that's okay. So the table that we've used for quadratic in the past, just making a quick x and y table. So we got x's and y's. We would do -2, 4, -1, 1. I'm going to zoom in a little bit. 0, 0, 1, 1, and 2, 4. The inverse, just like we've done in the past, the inverse, you flip-flop the x and the y. So the inverse would be the x coordinates and then your y coordinates. And so instead of -2, 4, we'd have 4, -2. Instead of a -1, 1, we'd have 1, -1. Again, just flipping the rest of these, 1, 1, 4, 2. And the inverse would look a little something like this. So the inverse, 4, -2, we got 1, 2, 3, 4, 1, 2 down below. Then we have 1, -1, that looks right there, 0, 0. Then we have 1, 1, and then 4, 2. So this would look something like this. This is not my best drawing ever, but you can kind of see the point. If we were to draw the inverse itself would fail the vertical line test miserably. The inverse would not be a function in itself. The original function is a function. So one way we could prevent this, instead of having to go through and find every point, is to do a horizontal line test. So on the original graph, or on the original x squared, if you were to draw a horizontal line, that's as if you were to draw some vertical line through the inverse graph. But the horizontal line test, if it passes more than one point, if it touches more than one point on the horizontal line, that means its inverse is not a function. So we're going to use that as kind of a starting point to see whether or not we should even just continue with what we're doing. So looking at the finding the inverse of the function directions says, use the horizontal line test, what we just talked about, to decide whether f has an inverse function. And if it does, then we keep going. If it doesn't, we stop. Let's next up, we got for the equation, we're going to flip f of x and we're going to make it y. We're just going to start with that. And then we're going to flip-flop the x and the y. That's step 3. And then the last one is we're going to solve, goodness gracious. In step 3, we're going to flip-flop the x and the y. So if it's y equals, it'll become x equals. And then we're going to solve for y. In the last step, we're going to make sure we're using that proper inverse notation, which we'll practice in a second. So for letter A, it says 5 minus 3x over 2. I'm going to keep the directions there. So the first thing, I'm going to just graph this, and I would encourage you to graph this on a graphing calculator or on Desmos or what have you. I'm just going to zoom in on the picture here so you can see it a little bit easier. So here is the graph of 5 minus 3x over 2. Looks a little something like this. So if we draw vertical lines, obviously it passes the vertical line test over and over and over. If we draw horizontal line tests, it passes the horizontal line test as well. So its inverse is a function. So now it's past part 1. Let's move on to part 2. Part 2 says exchange f of x for y. So we're going to, instead of f of x equals, we're going to make it y equals 5 minus 3x divided by 2. Step 3, really, it's something, if you think back to algebra 2, there was a lot more involved in 3. We did some very specific processes. We're just going to keep it general, but there's a lot that can go on here. So part 3 says interchange the roles of x and y. So instead of y equals, we're going to make it x equals. Instead of 5 minus 3x, we're going to make it 5 minus 3y over 2. So now to start solving for y, we're going to multiply both of those sides by 2. And we got 2x equals 5 minus 3y. Keep solving for y. We're going to get rid of that 5. So we're going to subtract 5 from both sides. So we have 2x minus 5 equals -3y. So make sure that minus sign stays there. It's easy for that to accidentally disappear. So keep solving for y. I'm going to divide both sides by -3. And we're going to end up with 2x minus 5 over -3. Doesn't really matter where that negative goes. You could put it up top, down below, out front. I would probably put it out front, but you can leave it as such. So step 4 says write it in proper notation. So we write this thing, it looks like it's f to the negative first, but we read that it's f inverse of x. So f inverse of x equals 2x minus 5 over negative 3. That is a perfectly acceptable answer. Or if you wanted to, you can divide both the 2x and the negative 5 by negative 3, which would give you f inverse of x equals negative 2x over 3 plus, because if you have negative 5 divided by negative 3, it'd be plus 5/3. Or if it helps you, just a slight variation, negative 2/3 x plus 5/3. That's kind of nice because then you can see it's a linear graph. So that's one way of writing all these. So, well, let me rephrase that. It's 3 ways of writing all the same answer. Letter B, let's give this a shot. So again, we're going to skip step 1, even though we did step 1 for the first one. I'm just going to tell you these are going to have inverses. We don't need to worry about it. Or inverses that are functions, to be specific. So the first thing we're asked to do is set it equal to y equals, instead of f of x equals. So we got y equals the square root of 2x minus 3. Step 3 is the big jump. Step 3 is switch them and solve. So we have x equals the square root of 2y minus 3. And now we got to solve for y. In order to solve for y, we got to square both sides. And we end up with x squared equals 2y minus 3. Keep solving for y. We're going to add 3 to both sides. We got x squared plus 3 equals 2y. Almost have y all by itself. We just got to divide both sides by 2. And we end up with x squared plus 3 over 2 equals y. For step 4, again, putting it in proper notation. So I'm going to say f inverse of x equals x squared plus 3 over 2. Or if you want to rewrite that as 1/2 x squared plus 3 over 2, that's another way of writing it. So two separate ways of writing that same answer. Take a moment, pause, and see if you can start working on letter C. And of course you pause and we're back. So letter C, starting off with the same steps. So step 2, step 1, we're going to assume that it passes the horizontal line test. Step 2 says y equals, instead of h of x or f of x or what have you. So 8x minus 4 over 2x plus 6. Now something that might make this a little bit easier, I'm not going to do that. I changed my mind. So we got 2x plus 6. To start solving step 3, we're going to make it x equals 8y minus 4 over 2y plus 6. To solve for y, we got to get y out of the denominator. It's kind of a mess. But before we do that, this is what I was getting to a second ago. I was getting ahead of myself. Looking at the numerator and denominator, 8y minus 4, 2y plus 6, they all have a common factor of 2. So we can actually divide every term in there by 2, which would give us 4y minus 2 over y plus 3. Just a little bit smaller numbers to deal with. Now to solve for y, we're going to multiply both sides by y plus 3. So we're going to multiply both sides by the denominator, and we're left with, let's see, x times y, because we're distributing, plus 3x equals 4y minus 2. Cleaning this up a little bit, we'll subtract 2 from both sides. And I'm going to run out of space here pretty quickly, so I'm going to move this workspace over here. So now we're at xy plus 3x minus 2 equals 4y. To keep solving for y, let's get all the y terms on the same side. So I'm going to subtract xy from both sides. So now we have 3x minus 2 equals 4y minus xy. Now again, we're trying to get y all by itself. Let me shift this a little bit over. We're trying to get y all by itself. But now looking at that left side, they both have a common piece, a common factor, if you will, of y. So what we can do is we can factor that out and make it y times whatever's left, and we factor a y out of both of those pieces. So we're left with 4 minus x. So we have y almost all by itself. Now we just got to get rid of that 4 minus x. So it's y times 4 minus x. So we're going to divide both sides by 4 minus x. And I'm just going to rewrite that left side a little bit. We got 3x minus 2, 4 minus x. Just to put it in standard form, we're going to say negative x plus 4. And on the right-hand side, we're left with just y. So step 4, rewriting that in proper inverse notation, f inverse of x equals 3x minus 2 over negative x plus 4.